Hi guys, welcome to my 7th processing tutorial. Today we're going to go through the accelerometer. They've actually added a accelerometer example into processing now. So if you go to the examples in Android mode, and then have a look at sensors, you've got the compass and the accelerometer. So if we click on accelerometer, double click on it, it should come up with the accelerometer example here. And if I just show you that, it's got an Accelerometer Manager class. It's quite a big class. So what you want to do is just Control A, Control C, bring it into your sketch. So create a new class called Accelerometer Manager .java, and then just paste it in. In fact, it's not one class. I think it's a collection of classes. If you look through it, you should be able to see. Let's have a look. No, it's just one class. Yeah, called Accelerometer Manager. So what it does is it imports the Android hardware sensors. Well, it imports the package Android.hardware. What I'm going to do is just go for an example with you on that. So we'll start off by, if we want to use the Accelerometer Manager, there's a few other bits we need. In the example it's shown here, this is what they do. They have, in their setup, you have to initialize the accelerometer. So you say, so you say Excel equals new Accelerometer Manager this. So it applies to this class. And you'll also want to specify an orientation, really. You don't have to, but it's better if you do. It saves your application from going a bit buggy. Here it's specified in portrait, so we'll just use that for the minute. So if I just copy paste these bits, get rid of the no loop. Well, it doesn't matter about the no loop, it's just void setup, isn't it? So void setup. So we've got that. We will need the resume and pause and shake event. Yeah, well, we'll put it all in there. Just got to paste it in there, and then you've got your acceleration events. Now, what this does is it takes these three variables here, x, y, and z, and it says the ax, ay, and az is equal to x, y, and z from the acceleration event, which is basically where it detects whether or not it detects the x, y, and z position of your accelerometer. So if you're tilting it left or tilting it right, the x and y position changes. Tilt it up and down, the y position changes. I don't really know where you would use z. You can put that in the comments in the YouTube video if you've seen it used somewhere. But anyway, we'll copy this in. So I'll just put that here, and then what we need to do, well, that's it really. That's the Accelerometer Manager imported, if you like. It's got all the methods we need: the acceleration event method, shake event, pause and resume methods. This one here. Going to show you it practically applied. So we have got everything we need, haven't we? Yeah. Okay. Brilliant. I'm going to create a new class, and we'll call this class falling balls. So we're going to create some falling balls. So yeah, let's start off by creating the class falling balls. So we're just going to create a new class. So in the construct, well, let's create some variables to use. So we're going to have an x, y position of the ball and the size of the ball. That's going to be quite important. We'll also have a float as well for the speed. We want the speed to be as variable as possible, so by using a float it means it can be more precise, as opposed to using an integer which is only 1, 2, 3, 4, 5. We'd rather have it as like 1 point da 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 da, as opposed to just 1. Okay, so that's why we're having that as a float. So if I create a falling balls constructor, and in the constructor we'll be passing in the variables for x, y, and the size and the speed. So what we'll probably want to do is have them named differently. So let's say in XA, in YA, in SI for speed, and then it was a float for, sorry, SI for size, it was a float for speed, so we'll just say float SP. Okay, and then what we'll want to do is say the x in this class is equal to the xa that we are passing in. So the x that we are passing in and the y that we are passing in will be equal to the x in here and the y in here. So y equals y as well. There you go. So this is only going to be used in this constructor here. It's taking variables from wherever we decide to pull the variables out from, and then setting the value of these variables to the variables we're storing here, if you like. So we also need to specify the size. So the size is what we called it. The size equals SI and speed equals SP. So this is what we put in our constructor. So each falling ball we create, theoretically, when we do create it, we'll take these variables which we will play around with later. Okay, so that's our constructor made. Let's create a update method. This is, you can call your method whatever you want. I'm just calling mine update to make it easier to understand exactly what it's doing. And what we want to do is fill the ellipse with a color. We want to make sure that the ellipse has its x position, its y position, and its size. Because remember the ellipse method built into processing takes these four variables, which is the x position, y position, width, and height of the ellipse. But because they're balls, we just want them to be equal in width and height, so we've specified e size for both of these. So what I'll also do is say, so let's actually think about what we're going to use next. Okay, so as I was saying before, in the Accelerometer Manager, it gets the x, y, and z position using this method here, the public void acceleration event method, which has the x, y, and z variable being passed in. So it's what we've done at what we need to do at the top, which we haven't done. We need to specify these three floats, because if we haven't specified them, then that's going to have an error and say that it doesn't exist. So yeah, float ax, ay, and az. That stands for, well, acceleration x, acceleration y, acceleration z, I assume. And we basically said these x, y, and z variables that are being passed in from the accelerometer now become the global variable we've created, ax, ay, and az. Update that, and we're just calling redraw here because it's not using a standard method within the processing development environment. It's actually using something from Google's development libraries, so we have to redraw that because otherwise it only gets called once. So that will just continuously redraw. It's kind of like sticking it in a while true loop outside of this. And now what we're going to do here, we're going to specify the x and the y speed, the rate at which the x and the y move. So let's start off with the x. On my phone, the accelerometer is backwards, so we have to do x minus equals ax times speed. So ax is the acceleration, the x acceleration, which is being updated all the time by the phone's accelerometer using the Accelerometer Manager, times the speed. And we've already specified the speed here. We haven't actually set it to anything yet because we're still building this class. But what we'll do is we'll set speed to maybe a random variable, or we'll base it upon maybe the size of the ball. Well, we'll do that later. But that's basically how it would go. You're saying the x is minus the rate of acceleration times the speed at which we wish for it to move. The other one is the y. Because the y on my phone isn't backwards, the accelerometer, the acceleration of the y isn't backwards on my phone, and we can say y plus equals ay times speed, and that should be fine. That should work properly, and that's it for that. What we also will want to do is make sure that these falling balls that we create don't go outside don't go outside the screen of the phone, if you like, so that they're always on the screen. So what we'd specify here is if, let's have a think about this one. So if x is greater than the screen width minus the size of the ball, then if I just copy paste this bit, x equals screen width minus e size. So it's saying x is equal to this, don't go further than this, basically. And we can do the same if x is less than 0 plus e size. The reason why I'm saying minus e size and plus e size is because we don't want it to go, we don't want it to go outside the box at all. We want it to stay as though it's hitting the edge of the box, right? Or the screen, I should say, hitting the edge of the screen. So we're saying if x is less than 0 plus its radius, then x is equal to 0 plus its radius, so that it doesn't go any further. If we just move on to y as well, so if y is less than 0 plus e size, y equals 0 plus e size. And you can copy paste this one as well, because it's the same, but just changing the x to a y. If y is greater than screen width minus e size, y equals screen width minus e size. So there's our collision detection. I'm just going to put in this to say the collision detection's ended. There we go. So we're still in our update method here. I should make it clear where the update method ends as well. You know, I'm just going to do an auto format on that. There you go. Makes it a bit clearer now. Okay. And okay, so now that we've done our collision detection, that's pretty much the falling ball class set up for the basics anyway. So now let's go back to our main draw method, which we haven't even specified yet. We'll specify that now. What we're going to do is, well, set up a background. That's a good start. Stick it to 0, so we've got a black background to work with. We will need to specify, if we're going to do an array of balls, we'll need to specify an array. So falling balls is the name of the class, and we're going to create a array called falling balls, and we're just going to say it's equal to new falling balls, the class name again, and we're going to say there's 20 of them. So it's an array of 20 falling balls. Does that make sense to everybody? What I'll do is I'll just try and make more sense of it. So we've got our class falling balls just here, class falling balls, and we're creating a new array. This can be called anything. We can call this herpy derpy. We can call it anything we want. Herpina. We can call it anything. So we'll just call it falling balls. But yeah, you can call that array anything because it's your own name for that array, and you're just basically saying it's equal to 20 new falling balls, 20 new falling balls classes. So in the setup, we'll need to set them variables that we set up these variables earlier in our constructor for falling balls. So this is kind of like the setup of this class, if you like. So what I'm going to do is call that constructor within our main setup of the processing sketch. So we're going to say for int I equals 0, I is less than falling balls dot length. So we're saying this variable I is equal to 0. So whilst I is less than falling balls dot length, add 1 to I. This is what we're saying. And what we're going to do is start setting variables for everything. So the size, I think we should have that random. So the size needs to be a random variable between 25 and 50. That seems fair, I'd say. However, there's one problem here. The random method in processing is a float. It generates a float, I should say. And by calling it like this, it will generate a float between 25 and 50. And we need it to be an integer. So the way we do that is cast integer on it, like this. I'll cast it as an integer, I'd say. Okay, so int si equals int random 25 to 50. That's what we've got for the size at the moment. So it generates a random size between 25 and 50. Now let's move on to the speed, which is a float, and we're going to say that's dependent on the size. So whatever the size is, times that by 0.1, and that's our speed. We don't want it to move too fast, so so 0.1 is a sensible amount. Maybe 0.2. Yeah, 0.2. And now we move on to the x and y position. So this will be random, I think. Let's say okay, so we want it to hit the wall, we don't want it to go beyond the wall, so we'll do this. So that's the size of the ellipse in between, it will generate a random integer in between the size of the ellipse and the screen width minus the size of the ellipse, so within them boundaries. And we'll do the same for y, except it's screen height, not screen width. So let me just put that in a capital letter for you. There. Okay. Now we've got our falling balls variables set up for us. We want to create an array. We want to call the we want to create we want to call the constructor of the falling balls using this. Falling balls I equals new falling balls x, y, si, sp. If you're a bit confused by this point, you're not quite sure what this does. This is the array that we set up. So we said, we've got an array of 20 falling balls here. An array of 20 falling balls. And whichever value I is on, so for that value for that falling balls class in the array of falling balls classes, whichever falling balls class it is in the array, then call the constructor of that falling balls and put in the x, y, speed and size, which we've defined here, into this falling balls class. So we've created 20 of these classes, and we've specified an x position, y position, size and speed. X position, y position, size and speed. And you can see here in the constructor, it's got its variables private to that class, the x position, y position, the size and the speed, which it's taking from the constructor over here. It's taken from where we've constructed it here and specified the speed, the x and y position, and it's done that so differently every time because it's generating these random numbers which influence all of them. So give it a try. It should make sense after doing it a couple of times, and you'll understand what's going on. In the draw method, we'll need to call update as well. Remember earlier we made the update class, the update method in the falling balls class, which is here. Is the update method, this bit here. So it's got the collision detection, and it just fills an ellipse and moves the x and y position by the speed, by the acceleration and speed. So what we want to do now is do the same thing here for in I equals 0, I is less than the falling speeds dot length I plus plus. Paste that here, and then we want to put in the call to that method. So falling balls I, so whichever falling balls it is in that array, is it the first falling ball, the second falling ball, the third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, you get the idea. The I, that's what the I represents there, because I will be incrementing until it gets to the length of falling balls, which is 20. So falling balls I dot update. So we're calling the update method for each one of them falling balls in the each one of them falling balls classes, because they all have their own update method. Okay, and actually this should run. Have we got any mistakes? 5 errors. Okay, so void pause, excel.pause. Have I specified the accelerometer at the top? I don't think I have. I need to say accelerometer, no wonder, accelerometer manager Excel, that'll do. That should fix that error. And that's it, there's no other errors. Amazing. Okay, so I'm just running it on the device now so you can see. Here it is. Here it is. So what we've created is this little thing which moves around. Seems to be a little bit of a problem. I'll have to have a look at the code and see what I've done wrong there. Because if you look, it's only stopping halfway up the screen. I'm not sure why though. Let's have a look. We found that it was stopping halfway up the screen. I'm just thinking what could cause that. Let's have a look. Did I put in something wrong? You probably noticed it in this video and I didn't. X is greater than screen width, X equals screen width, Y, aha, here we go, here's our problem. Our collision detection is detecting it as screen width because I copy pasted and forgot to change the screen width to screen height. There you go. Okay, so you probably noticed that about 10 minutes ago and was like, oh my god, he's left it. But I've corrected it now. So when we load it, it will run properly and it won't do something random like that. Okay, so I'm starting it again on the device. I'll record this for you. So again, there it is. You can see it's all moving, as we want now. Quite fun. Anyway, let's make it more interesting now. Now we've got a falling balls class working and we can specify as many of these random falling balls as we want. Let's say 50 to make it more fun. We can play around with the variables a bit more. I think the sensitivity on the movement speed of X is a bit rubbish, so let's just times all of that by 2. Yeah, let's do that. Times it all by 2. And we can also specify a fill value. So what we do is we just add an extra variable global to this class. So let's call this color col, and so color's a keyword, so we just call it col, and say in the constructor col equals random, say int random. In fact, let's have our red, green and blue values. So r equals int random 255, so that will do 0 to 255. Say the same for g and b. So we get random values generated for all 3 of them. So fill RGB, and we can put in a bit of opacity as well. Let's just stick it to 127, and we'll run that. We should get something a bit more interesting. So I hope you can see what's going on there. You can see they're all different colours now. What we'll do is, whilst this is on, we'll just move it a bit. I'll just change the colour. Sorry, just change the size. We'll say random 75, 150. So we get much bigger balls. Her. So you can see it started up now. You can see it way more clearly. Looks a bit mental already, doesn't it? Okay. So that's pretty much all I can tell you about the accelerometer this tutorial. I've probably blown your mind away with even more concepts as well. So thank you for watching this tutorial. I'll see you next tutorial. Next tutorial I'll start going through some of the inbuilt methods in processing. So I'll see you next time.